Today we are going to be writing and solving matrix equations. We are first going to write a matrix equation to represent each system, then identify the coefficient matrix, the variable matrix, and the constant matrix. Okay, so looking at example number 1, notice we have 6x plus 4y equals 18 and 8x equals 5y. We have solved systems of equations before, but now we're just going to do it with matrix. Okay. Now, in order to start, we do need x and y on the same side of the equal sign for both equations. So this 8x equals 5y, I'm going to rewrite as 8x minus 5y equals 0. So these are the two equations I'm going to be focusing with, okay? All right, so how we set this up is 6, 4, 8, and negative 5. I'll explain why it gets set up like this in a second. And then we have x and y equals 18, 0. Okay, so probably wondering why this is set up the way it is. Well, when we multiply matrices, we multiply the row by the column. So when I do 6x multiply 6 by x and then 4 times y, okay, and that equals the 18 spot. I have 8x, okay, 8x, and I have negative 5 times y, and then equals 0. Okay, so that's why this is set up the way it is, because when you multiply matrices, you multiply the row by the column. Okay, all right, now we need to identify each matrix. This first one is the coefficient matrix because the 6, 4, 8, and negative 5 are all the coefficients. Okay. X, Y is clearly the variable matrix because those are your variables. Okay. And then 18 and 0 is the constant matrix because those are your constants. All right, that's simple. All right, let's set it up for number 2. Notice we have 3 variables here, x, y, z, x, y, z. We're going to have to rewrite this in that form. So we've got 4x. I don't have any y, so I'm going to write plus 0y there to fill in that spot, plus 8z equals 0, because I'm going to add the negative 8z over to the other side. So now I have 1, 1, 1. Those are the coefficients. I have 3, 1, negative 2. Make sure that the x's are lined up together, the y's and the z's are lined up together, okay? 4, 0, and 8. All right, and then those are x, y, z. And again, because I get 1x, 1y, 1z, 3x, 1y, negative 2z, 4x, 0y, 8z, okay? Equals 24, 18, and 0. Okay. Again, these are the coefficients, so this is the coefficient matrix. These are variables, so this is the variable matrix. And these are the constants, so this is the constant matrix. Okay, alrighty. So here we have some tables at a graduation party will seat 6 people and some will seat 8. There will be 7 tables in all with seats for 46 people. Write a system of equations in 2 variables that can be used to find the number of tables with 6 seats and the number of tables with 8 seats. All right. So we've got the number of tables, 6 people can fit at let's say, the tables of X. And we can have 8 people at the tables of Y. Okay? And we need to be able to see a total of 46 people. So this equation represents the total of people. Okay? And then we are told that there will be 7 tables in all. So X was the tables that sit 6 people, Y was the tables that sit the 8 people, and that gives us a total of 7 tables. Okay? All right, now we're going to write the system as a matrix equation. Move this down a little bit. All right, so let's see here. We've got 6, 8, 1, 1. Those are my coefficients. Notice the X's and the Y's are lined up, so I did that right. So I've got X and Y, and quick check. 6X, 8Y, 1X, 1Y. Equals 46 and 7. Okay? All right, now we're going to identify which one is the coefficient matrix. Well, we've already talked about that. It's just the coefficients from the system of equations. So 6, 8, 1, and 1 is the coefficient matrix. Okay? And then just a reminder, like earlier on when we started the matrix unit, that the matrix times the inverse matrix equals an identity matrix with the 1s and the 0s. Okay? All right, so let's talk about the inverse matrix. Okay, we're going to use an inverse matrix to actually solve these systems of equations now. Okay, so we talked about the setup, now we're actually going to solve it. These are the 4 steps that help you solve the matrix. Okay, make sure that you write down these steps. All right, so if you need to, pause the video for a second and write down these steps, but here we go. So it says use an inverse matrix to solve, show the inverse and where it belongs, but use the calculator to actually multiply it out. Okay, so first we're going to find the determinant. Now remember, to find the determinant, we're going to multiply the 3 and the 5, and we're going to subtract it by the negative 2 times 8. So I've got 3 times 5 minus negative 2 times 8, which, what is that? 15 plus 16 equals 31. Okay, so there's my determinant. Now we're going to find the inverse matrix. Okay, now remember, you're going to divide, or you do 1 over the determinant times, remember the 5 and the 3 switch spots, and then you change the signs on the 8 and the negative 2. This becomes negative 8 and this becomes positive 2. And let's go ahead and simplify that. Okay, so this is just scalar multiplication. I'm going to multiply all these by 1 over 31. So I get 5 over 31, negative 8 over 31, 2 over 31, and 3 over 31. And notice that none of these simplify. None of these fractions do. Okay. Now, if you want, you can go straight to this step. You don't have to show this step. Okay, but just wanted to remind you guys that that is how you find that. And that's the inverse matrix. Okay. All right, so then now to solve, we're going to take the inverse matrix. So this guy, 5 over 31, whoops, 2 over 31, 3 over 31. And we are going to multiply that by the constant matrix, 14, what was it, 32? Okay, so we're going to multiply those together. So in our calculator, let's type that in. Remember, you have to go over to edit, type in your matrix, and hopefully you guys can still see that okay. Okay, it won't let me change it to a fraction. That's okay. All right, but just make sure you type those all in, right? And then, let's see, I need to type in matrix B as a, oh, whoops, 2 by 1, sorry. All right, so that's 14 and 32. All right, so now I'm going to multiply the matrices. So matrix A times matrix B, get negative 6, 4. Okay, so the solution is saying that xy is equal to negative 6 and 4. So x equals negative 6 and y equals 4. All right, let's flip to the back. All right, let's consider the linear system. 3x plus 4y equals 6, and 6x plus 8y equals 24. We're going to write a matrix equation to represent the system. So my x's and y's are lined up, my constants are lined up, I'm good to get started here. So I'm going to have 3, 4, 6, 8, multiplied by xy. Again, that should make sense. 3x, 4y, 6x, 8y equals 6 and 24. Okay. All right. Now we're going to find the determinant of the coefficient matrix. So here's my coefficient matrix. I'm going to do 3 times 8 minus 6 times 4. 24 minus 24 is 0. Okay. All right, now we're going to graph the linear system. Well, in order to graph the linear system, we need to write this in slope-intercept form. So let's see here. I'm going to do this equation first. So I get 4y equals negative 3x plus 6, and then divide everything by 4. So negative 3/4 x plus 6/4 reduces to 3 over 2. So I'm going to use that. And then for this equation, I get 8y equals negative 6x plus 24. Let's see here, divide everything by 8. So 3/4 again, negative 3/4 again. 24, oopsies. 24 divided by 8 would be 3. Okay. All right, so let's go ahead and plot these. So that's 1.5. Go down 3, 1, 2, 3, right 4, 1, 2, 3, 4. Okay, yeah, we're good. All right. Let me get. Use this note card as my straight edge. Okay, and then I've got positive 3, then down 3, right 4. Didn't connect to those dots. Okay. Notice that it says, what does the graph indicate about the system? Well, these lines are parallel. Which means what? They don't intersect, so no solution. Okay? So this is saying that this system of equations has no solution because graphically the lines are parallel, so therefore they never intersect to give you an x and a y value there. Okay? So on number 3 it says consider the linear system. All right. Let's find the determinant of this linear system that we have here. Well, I'm going to write off what the matrix will look like off to the side real quick. So we have 1, -3, 3, -9, xy equals 8, 24. Let's get some good practice in here, okay? All right, so the determinant, I'm going to do 1 times -9 minus 3 times -3. So that gives me -9 plus 9, which equals 0. What do we know about these lines before even graphing it? Go back up to the example above. When we had a determinant of 0 and then we graphed the linear system, we realized that the lines are parallel and they don't intersect, so that meant no solution. So we can conclude that when we get a determinant of 0 of the coefficient matrix, we know that there's not going to be a solution because the lines are parallel and they never intersect. Okay? So the lines are parallel and never intersect. So, no solution. Okay. All right, last problem. What is the missing number in the following matrix equation given its solution xy equals 6, -2? So, this is saying that x and y are 6, -2. So let's plug that in. If my pen will work. Okay. There we go. So, we can do a couple different things here. All right. We can see here real quick that so row 2 times column 1 will give us this solution right here. So like -3 times 6 plus, and then we've got 2 times -2. So what is that? -18 minus 4 equals the -22. So we then can also do row 1 times column 1 and say 4 times 6 plus -1 times -2 equals, what is that, 24 plus 2 equals 26. Now, if you want to do this on a calculator, -1, -3, 2. Yep, okay. Oh, whoops. Gotta go down to matrix B. Okay, we need to change it to 6 and -2. A times B. And we see that we get 26, -22. So the answer is 26. The question mark equals 26. But again, you can do that by hand or on the calculator. Okay, I just wanted to show you both ways. Alrighty, that is it. See ya.